Right. So today we are going to discuss about the Kutzbach equation, right? So this Kutzbach equation, right, helps us to find out the number of degrees of freedom, right? So now, in order to determine that, right, there is an equation, right? So what is that equation? 3 times L minus 1 minus 2J minus H, right? So there, this L stands for number of links, okay. J stands for number of joins, right. H stands for number of higher pairs, right. So now let's see what is a higher pair, right. So I will give you an example for a higher pair. It is something like, just consider the mechanism between two gear wheels, right? You know that mechanism between two gear wheels, right? So now if I am going to consider the mechanism between two gear wheels, right, you can see that there we have a line of contact or a kind of a point of contact. Oh, another example, tire and the road, right? What you can actually observe, if I am going to consider the tire and the rod, is that there we have a certain point of contact at a one particular time, right? We have a point of contact. And another example is that the follower and the cam and the follower, because there also we have a line of contact, right? Or a certain point of contact at a particular time, right? So these are the examples for a higher pair, right? So now let's discuss some examples. In other words, let's say this link is fixed, right? Here we have a wheel, right? So what do we have here? Here we have a wheel, right? So let's give it some names, A, B, C, and let's give a name to this wheel, that is D. Wheel D, right? So now this link AC is fixed. AC is actually fixed, right? So it is. So we can give it the label 1, right? Fixed link. C, second link, number 2, right? B, C, third link, right? Third link, right? And then what about this wheel, right? So that wheel is also kind of a one member in this mechanism, right? So let's give another label for the wheel, label number 4. What is the first label there? This AC, that means the link AC. Let's give it a label 1. Link AB, label 2. Then link BC, label 3. Then this wheel D, so let's give it the label number 4, because now they are actually what we refer by links. We can call it, right, number of links, right? It is somewhat similar. So we can also consider number of links as, you know, that number of members of the family of this mechanism, right? Number of links, that is something like, you know, number of members in this family, right? Okay. So L equals what? 4. How many joins are there? See, one joint. Link that connects the joint. Right? Joint that connects the link AC to this link AB. So here we have one joint. one joint, another joint, two. Then the joint that connects the wheel D with this link BD. You get the point, right? Let's not call it BD, let's call it the link BC, right? In other words, the joint that connects this wheel with this link or with this member, right? One joint, the second joint, and the third joint that connects the wheel to this member. So how many joints there? Three joints. How many joints? Three. Then how about this one? This wheel and this member AC. So there we have a point of contact. Got the point? Right. It is not a normal joint. It is something like we have something like a point of contact. Right. So that is a higher pair. So H is 1. Right. Okay. So right. So now you got the point, right? So what is the degree of freedom? Of 3 times number of links minus 1. 4 minus 1 is 3. 9 minus 2j. Minus 2j means 6. Minus 1. 9 minus 6 minus 1. Answer is 2. The number of degrees of freedom is 2, right? The answer is 2, right? Then another question, right? Another question, right? So let's carefully sketch it, right? So I will sketch it here. So now these are pinned joints, okay? Right. So let's solve this problem, right? So now here, this one, now actually this one is a one single plate, right? So what is this? This is a one single plate. Single plate. It is a one single plate, right? So don't mistake it as 3 links. 1, 2, 3. Not like that. This is a one single plate. So now let's give labeling, right, for the members, right? Right. So now here also, right, what is the first link? Oh, this is a very special point, right, where students make mistakes, right? So now here, okay, let's first do it like this. Now how many links are there? That means number of members of this family of mechanism, right? Like number of members, right? Let's say number of links, right? So let's calculate that with me together, right? This one, 1, this one, 2, this one, 3, right? This one, 4, this one, 5. Again, let's confirm it. 1, 2, 3, 4, 5, and this single plate, 6. So how many members are there in this family? 6. But if you say 6, it is wrong. Because the reason, right, if I'm going to consider this question, right, here just consider how can you connect this link with this joint if there is no any sort of a frame, right, or if there is no any sort of a foundation or a base, right. So because of that, here we have some sort of a base, right, or a foundation, right. So let's call it a foundation or a base, right, because otherwise how can we connect this link to this joint, right. So here also we have a base, right. So here also we have a base, right. But be very careful that all these three, now here you can see, here we have a one base, and here we have a one base, right, and here also we have a one base, right. But all these three guys, right, are on the ground, right. All these three guys are on the ground at rest, right, because the base is not moving, right. It is something at rest, right. So because of that, as all these three guys, right, or what we referred as base 1, base 2 and base 3, right, all these three guys are at rest, right. So we will give it a one labeling, right. So this base that is at rest we consider as a one member of this family. So let's add 1 for that. Even though here we have 3, right, as all of these 3 are at rest, right, we will just consider it as 1. So how many members or how many links are there? 7. 6 plus 1 will be 7. 7 links. 1 link is for the frame, right. That means this is first link, second, third, fourth, fifth, sixth. What is the seventh one? This one is the seventh one. How about this one? This is also seventh. How about this one? That is also seventh, right, including the base, right. So how many links are there? 7. Then how many joints are there? How many joints? Very good. One joint here, second joint, third, fourth, fifth, sixth, 7, 8. How many joints we have? We have 8 joints. Again, now here we have a pinned joint, P-I-N-N-E-D. Here also we have a pinned joint, and here also we have a pinned joint. So anyhow, here we have a joint. Joint 1, 2, 3, 4, 5, 6, 7, 8. Right. So how many joints? 8. Any higher pairs we have? HP? No higher pairs. So degree of freedom formula: 3 times link minus 1 minus 2j minus higher pairs. Link 7, so that means 3 times 6 minus how many joints? 8. 2 times 8, 0. Then 3 times 6, 18. 2 times 8, 16. 18 minus 16, 2. So degree of freedom or number of degrees of freedom for this system is what? 2. Right. So now the very first thing, right, we have to find the number of members, right. So we call it number of links, right. So now just focus these parts, right. Now this is something like ground, right, where it is fixed to here, right, or in other words where this now here you can see, here we have a pinned joint, right. So here also we have a pinned joint, right, I mean this one, right. and here also we have a pinned joint, right? So now, as we know that this pinned joint, right, that is connected to somewhere, right? So in other words, this pinned joint is connected to the ground, right? So now, as I have discussed in previous examples, right, so this fixed ground like thing, right, so this ground also we consider as a member, right, but we are not going to give different labels, we are going to give only one label, right? So that means this ground, right, or this, in other words, this base, right? So to this base also we are going to give a number, right? In other words, this base we are going to consider as a member of the family, right? So let's give it a label, label 1, and label 1, right? Okay. Then consider this link. So it is number 2, right? And this is a one single plate, and this is also a one single plate, and this is also a one single plate, right? So then okay, so then label number 1 is okay, then label number 2 is this link, label number 3 is this link, and label number 4 is this link, and label number 5 is this link, right? Label number 5, right? Then label number 6 is this single plate, and this plate is label number 7, right? And this plate is label number 8. So how many members we have? We have 8 members, right? Member number 1, 1, 1, then 2, 3, 4, 5, 6, 7, 8, right? So how many links? 8. As you can see, there are no higher pairs, right? So no problem, no doubt, no higher pairs, or in other words, point connections, right? We cannot see any line of actions, such as I have discussed as an example. In this problem we cannot observe anything like geared mechanisms, right, or rollers, or in other words tire and rod like connections, right? We cannot observe such type of connections, so no higher pairs, right? So higher pair is 0. And the next thing is number of joints, right? Number of joints. Now let's carefully calculate the number of joints, right? So if I want to consider this pin connection, right, here we have a one joint, right? Got the point? So here we have one joint, joint 1, joint 2, and joint 3. 3 joints, right? Joint 4, joint 5, right? And then joint 1, 2, 3, 4, 5, right? Then joint 6, 7, 8. Joint 6, 7, 8. Anything else? Then joint number 9 here and joint number 10 here. So how many joints? 10 joints, right? 10 joints we have. Again, joint number 1, 2, 3, right? That means the joint that connects this link to the ground or to the frame, because of this pinned joint, right? Joint 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 joints. So according to the equation, degree of freedom will be 3 times number of links minus 1, 3 times, that means 3 times 7 is 21, minus 2 times number of joints, 2 times 10 is 20. So degrees of freedom, what is the answer? It is number 1, right? So now in this question, right, this is a one single plate, right? So this is a, see this one, this is a one single plate, right? one single plate, right? And how about this one? So this is also a one single plate, right? And here we have a pinned connection or pinned joint. So here also we have a pinned joint, right? Pinned joint, right? That means this joint is actually made on a certain base, right? On a certain ground, right? So this ground also we consider as a member, right? So this is also a ground that is at rest, right? So we will give it the label number 1, right? Because of the so this connection, right? Because we know that this is something like the ground which is at rest, right? So in other words, this is something like the base, right? So this is something like the base, right? This is something like the base, right? So to this base also we will give a label, right? So we will give it the label 1, right? Here also we will give the label 1, as we know that we are not going to consider these two base elements as two different things, right? Label number 1 and label number 1, right? That means now we need to find number of links, right? The number of members of the family, right? So because of this fixed base, right, or because of this fixed ground like thing, we give it the label number 1. Then label number 2 is this plate. This plate is label number 2, right? This plate label number 2. Then this plate label number 3. Then this link label number 4, right? And this link label number 5, right? Label number 1 1, 2 3 4 5. So how many members we have? 5. So number of links 5, right? And then number of joints, right? And you know that this plate, this one single plate is connected to the base, right, with the help of this pinned joint, right? So here we have one joint number 1, and here also in the same manner joint number 2, 3 4 5 6, total 6 joints, right? Joint number 1 2 3 4 5 6 joints. Got the point, right? Because that means now this is the joint that connects this plate to this link, right? And this is the joint that connects this link to this plate, right? So total number of joints 6. So as you can see here also we don't have any higher pairs, right? So now let's consider the equation for the degree of freedom. 3 times number of links minus 1, 3 times 4 12, minus 2j, 2 I 6 is 12, 0, degree of freedom 0. So if it is 0, so if you are getting an answer like DOF equals 0, that means it is a rigid structure. That means what? It is a rigid structure, right? Rigid structure. Here let's name this link AB, then BC, okay, then CD, right, then BE, right? So this is link AB and this is link CD, right? And this is link CB and this is link BE, and this one is piston F, or in other words let's call it slider F, right? So what is this item? This is what we call as the slider F, right? Okay. So now here we have a pinned connection, right? So here also we have a pinned connection, right? Pinned connection, right? So now here we have a base, right? As we all know, here we have a base, right? Which is at rest, right? So base is something that we consider as the ground, right? So here also we have a base, right? So now this link CD is connected to the base, or this link CD is connected to the ground with the help of this pinned joint, or through this pinned connection, right? So like that, this link AB is connected to the base or to the ground with the help of this pinned connection, right? So here we have a slider, right? Slider that is going, towards the front direction. It is something, it is going like this, towards front direction or towards the other direction, right? Something going like that. Here we have a slider, right? Okay. So now let's consider this family of mechanism, right? So how many links we have? This base, right, or this ground like thing we consider as a member, right? So this is the first member, is this ground, right, which is at rest, right? So label number 1, right? So here also label number 1, label number 1 and label number 1, and this one label number 2, and this one, this link label number 3, this link BC label number 4. So label number 1, 1, 2, 3, 4. Then label number 5. What is label number 5? Is this link BE. And what is label number 6? Is the slider or the piston, right? So label number 6 is the slider or the piston, right? And here also we have something like the base, right? Because here also, right, this slider, right, here we have a slider, right? So this slider is placed on a ground, right? So that also we can consider as the base, which is at rest, right? So for that also we can give the label 1, right? So how many links are there? 6 links we have. So now here you can see that this link AB, right, is connected to this ground, or this link AB is connected to the base, right, with the help of this pinned connection, or with the help of the pinned joint, right? And here also you can see the link CD is connected to the ground or to the base with the help of this pinned connection, or with the help of the pinned joint, right? So let's see how many joints we have, right? So now you have to be very careful. Here we have a one joint, right? So this is a one joint, right? Joint that connects link AB, right? Joint that connects link AB to the ground, right? So let's say like that, right? With the help of the pinned connection, right? And second joint is the joint that connects the link CD, right, to the ground, right? Okay. So now two joints are okay now, right? And now focus here. Here we have link AB, right? So now this link AB is connected with the link BE. Be very careful. And again, the link AB is connected to the link BC also, right? Got the point, right? Now here this link AB is connected to the link BE at the point B, right? Or at the end B of the link AB, right? Link AB is connected to the link BE at the junction B. So here we have one joint. But not only that, the link AB is also connected to the link BC, right? So here we have to consider that there are two joints, right? Not only a one joint. So here we have two joints, 1 and 2. Two joints, right? For what? So let's call it like this. One is link AB to link BE, other one link AB to link BC, right? Now okay, right? So now how many joints we have? 1, 2, 3, 4, right? 1, 2, 3, 4. Then here also we have a joint that connects the link BC to the link CD, right? At the end C, right? Another joint we have that connects link BC, right? Link BC to link CD. Right. So what is the joint number? So let's call it joint number 5. Now be very careful. The other most important thing, right? So now here you can see this link BE is connected to this slider or to this piston. Right? That is another very important thing that you have to understand and you have to figure out. Right? Now carefully focus that this link BE is first connected. Right? First it has to be connected to the slider E. Right? So there we have a one joint. That is the joint that connects the link BE to the slider F. So that is joint number 6. Is that all? No. Another one more remaining. So that is the connection. That is the joint that connects the slider or the piston to the ground. Right? So that means here also we have two joints. One joint is the joint that connects the link BE to the slider. BE to the slider. What is the other one? Is the joint that connects the slider to the ground. Right? So 7. So how many joints we have? We have 7 joints. Right? I hope now you got the point. Right? So now degree of freedom formula tells us that 3 times 6 minus 1, 5, 15 minus twice the number of joints, twice 7 is 14, no higher pairs. 15 minus 14 is 1. So number of degrees of freedom or DOF is what? What is the answer? It is 1. Right? First of all, let me introduce you the members. Right? So here we have a one single plate. Okay. So this is a one single plate. Right? This is also a one single plate. Right? And this is also a one single plate. This one. And this is also a one single plate. Right? And let's give it a name. Right? So now this is a separate link. Right? This one, link AB. Right? And this is also a separate link, link BC. Right? Then link BE. Right? Then the other link, link CF. Right? So here we have the link AB, BC, link DE and link CF. Right? These things are, so this is a one single plate. Right? This is also a one single plate. Right? So total 2 plates, and this is also a single plate, and this one also a single plate. Right? So now we have total 4 single plates. Right? Okay. Now here the special case is that you have to be very careful, right? So now here just focus this plate. So I will give it a name. So let's give it plate 1. Right? Now this is plate 1. Okay. Now plate 1 is actually fixed to the ground. Right? So now what is this? This is the ground. Right? Or in other words, the base. Right? Because in order to mount, right, or in other words that in order to bear this system, right, we need a certain foundation, right, or in order to bear or in order to mount, right, we need a certain foundation, right. That means we need a certain ground, or in other words we need a certain base, right. So now here this base or the ground is definitely at rest, right. Now the most important thing is that this plate is actually fixed to the ground, right? Because of that, now definitely to the ground which is at rest, we are going to give label number 1. You know that, right? So now don't get confused because of this labeling. So at this moment I will just erase this labeling, otherwise you will get confused, right? We know that here we have a plate, right? Okay. So now this plate is actually fixed to the ground, right? Or this plate is actually fixed to the base which is at rest, right? So because of that, as this plate is fixed, we consider both the ground and this plate as a one single member, right? Because both are at rest, right? So to this plate and to this ground, right, for both of these members, they are going to give member label number 1. Got the point? Right. So that is the label number 1, right? So label number 1 is okay. So to this plate I will give a labeling alpha, plate alpha. That is better, right? Because if I give numbers, you will get confused, right? Plate alpha, plate beta, plate delta, plate gamma. Now okay, plate alpha, beta, plate delta, plate gamma, right? Okay. So the first member 1 is given to the plate alpha and base or the ground, right? So that is the label number 1, right? And this plate beta is label number 2. Plate gamma, label number 3. Plate delta, label number 4. Then label number 5 is this link AB, right? I am writing these things, otherwise you will forget, right? So label 5 is the link AB, and label number 6 is the link BC, right? Label number 7 is the link DE. Then label number 8 is the link CF, right? So how many members we have, or how many links we have? L equals 8. Now in this question there are no higher pairs, so H is 0. Now the next question, how many joints we have? That is the next target. So now we have to be very careful, right? That is the next most important thing, right? So now here we have one joint, right? So what is the joint? So that is the joint, right, that connects the link AB to the base, right? So that is joint number 1. Joint number 1 is the joint that connects the link AB to the base, right? Joint number 1. And joint number 2, what is joint number 2? Joint number 2 is the joint that connects the plate alpha with the plate delta. So 2 joints. Be very careful. So far we have analyzed 2 joints. Then joint number 3 is the joint that connects the plate alpha to plate beta. Joint number 3. Then joint number 4 is the joint that connects plate delta to plate gamma here. That is the joint that connects the plate delta to plate gamma. So joint number 4. Again, one joint, the joint that connects the link AB to the base, 1. Then second one is the joint that connects the plate alpha to plate delta, 2. Then plate alpha beta, 3. Then plate delta gamma 4, right? Then joint number 5 is this joint that connects the plate delta to link CF. Then be very careful. Now here there is a joint that connects the link AB to plate beta, right? Be very careful. There is a joint that connects the link AB to plate beta. So one joint. And there is another joint that connects the link AB to plate, not plate, right? And there is another joint that connects the link AB to link BC. So second joint, right? And now here there are several ways that you can actually analyze that, because you know that now actually here one person can say like that. One person can say, see, link AB is connected to plate beta. Okay, that is one joint. And link AB is connected to link BC. That is another joint, right? So someone can actually argue like that. And someone can also argue like this also. And somebody can say like this. First joint is the joint that connects the link AB to plate beta. And another person can say the other joint is the joint that connects plate beta to link BC. Somebody can argue like that also, right? The first argument is that link AB is connected to plate beta, and again link AB is connected to link BC. One method. Other method is that the link AB is connected to plate beta and plate beta is connected to link BC, right? But don't take unnecessary number of joints, right? So anyhow here we have 2 joints. So 5, 6 and 7. Right? Got the point? Right. Then here we have another joint, link. Now if you are going to consider this link DE, right? Now this link DE is connected to the plate beta at the end D. So another joint. And link DE is connected to plate gamma at the end E, right? So that is another joint. One joint here, another joint there, right? So now we have analyzed certain number of joints, right? Joint number 1, that is a joint that connects the link AB, right, to the base, right? Joint number 1, joint number 2, joint number 3, joint number 4 and joint number 5, right? Then joint number 6, 7, right? I have previously explained, right? 6, 7. Then 8, 9, right? Then now we have already analyzed 9 joints, right? Now just focus here. This link BC, right, is connected to the plate gamma, right? Link BC is connected to the plate gamma, right? And again this link BC is connected to the link CF, right? Right. Or somebody can argue like this. Link BC is connected to the plate gamma, right? And plate gamma, and this plate gamma is connected to the link CF, right? Someone can analyze in that manner also, right? So now how many links we have? Now we have total. So how many joints we have, right? So now we have total 11 joints, right? You got the point? So let's take a look again, right? First joint is the joint that connects the link AB to the base, right? Or the joint that connects the link AB to the ground. Second joint is the joint that connects the plate alpha with delta. So joint number 2. Then third joint is the joint that connects the plate delta with gamma, right? Joint number 3. And then joint 4 is the joint that connects the plate delta to the link CF at the end F, right? So joint 1, 2, 3, 4. Then joint number 5 is the joint that connects the plate alpha to beta, joint number 5, right? Then here we have joint 6, 7, right? Is a joint that connects the link AB to the plate beta and the link AB to the link BC, right? So now we have total 7 joints, right? Then this one, joint 8 and joint 9, right? Then joint 10 is a joint that connects the link BC to the plate gamma, right? That is joint number 10. And the other joint is the joint that connects the link BC to the link CF. So how many joints we have? So now we have total 11 joints, right? So that is clear. So total number of joints is now 11. So now according to the equation, degree of freedom DOF, right? So that equals 3 times link minus 1, 21. 3 into 7, 21 minus twice number of joints. Twice 11 is 22. The answer is minus 1, right? So now the answer that you are getting for the degree of freedom is a minus value, right? We call it is a superstructure. What? Superstructure, right? Or in other words, redundant condition. Redundant condition, right? We call it either a superstructure or redundant condition, or in other words, we call it is a statically indeterminate. It is a statically indeterminate structure. Right? So now, first of all, let me label the links, right? A, B, right? So this is a one single link, right? AB. Then link CD, right? AB, CD. Then BE, right? So this is link BE, right? So this is link DF, right? So this is link EG, right? And this is link FG, right? So now links are clear, right? And here we have a pinned joint, right? And here we have a slider, right? Or a piston, right? Right. And yeah. So now the first thing that we have to do is that calculate the number of links, right? Or to find the members of the family, right? So how many members are there, right? Now I have told you the first member is the ground, right? Or the base, right? So here we have the base, right? So the very first member is the base, right? So that is number 1, right? So here also we have number 1, right? Because anyhow the slider must be connected to the base, right? Right. Here also, in order to have this pinned connection, right? In order to make that connection, we need to have a base, right? That means this link CD is connected to the ground, right? Or to the base with the help of the pinned connection, right? Or the joint, right? So first link is the ground or the base, right? So we have number 1. This link AB, number 2, right? Then number 3, right? Then this link number 4, this link number 5, then this link number 6, and this link number 7, and any other link, yes, this slider, right? This piston is another link, right? So we have total 8 links, right? Shall we check again, right? The very first link is the ground, right? First one is the ground, right? First link is the ground. Second link is the this link AB, right? Link AB, right? Third link is the link CD, right? I'm writing for your better one, right? Then fourth link is the link BE, link BE. Fifth link is the link DF, link DF, this one. Then sixth link is the link FG. Then seventh link is the link EG, this one, right? EG, right? And eighth link is the piston, right? Eighth one is the piston, right? So are there any higher pairs here? You cannot see any geared mechanisms or roller mechanisms, right? We cannot observe any higher pairs here, right? So no higher pairs. Higher pairs 0, right? And the next thing, number of joints, right? Now carefully we have to calculate the number of joints. Here we have 2 joints, right? Here we have 2 joints, right? Why 2 joints? The first joint is the joint that connects the link AB to the piston, right? First joint is the joint that connects the link AB with the piston, right? So that is the joint number 1, right? Then second joint is the connection that is established in order to connect the piston and the ground, right? Or in other words, the base, right? Okay, so joint 2, right? That means here we have what, 2 joints, right? And here another joint we have, right? Joint 3. I will write it as J3. Is the connection between link CD and base. Link CD and base, right? Joint number 3, right? Then what? Now this is the fourth joint, J4, right? Fourth joint, right? Fifth joint, J5. Sixth joint, J6. Sixth joint, J6, right? Then seventh joint, J7 here. Then eighth joint, J8. Ninth joint, J9. Then 10th joint, J10 here. Shall we focus the number of joints again? Right? The first joint is the joint that connects the link AB with the piston. Joint number 1. Joint 2 is the joint that connects the slider to the ground. Joint number 2. Third joint is the joint that connects the link CD, this one, CD to the ground or to the base, right? Then 3 joints are okay. So here we have 1 joint, and here we have another 2 joints, right? That means first 3 joints are clear, right? So this is joint number 4, joint number 5, joint number 6, joint number 7, joint number 8, this one, and joint number 9, this one, joint number 10, this one here, right? So what is the joint number 10? Is the joint that connects the link EG with the link FG, right? Okay. And in addition to that, we have some cross joints also, right? see, these are the examples, right? Because here also at these intersections, right, the intersection of this link AB and link CD, we have another join there, right? Okay, so now I think that's clear now, right? Okay, so we have total 10 joints, right? Okay, joint here, joint, 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 and joint, right? So then J is number 10, right? So now let's focus the equation, right? 3 times number of degree of freedom equation, right? The equation 3 times number of links minus 21 minus twice the number of joints, twice 10 is 20, right? So degree of freedom is number. So now let's consider this problem, right? In here we have separate links, right? So first of all, let's name the links, right? We have link A, B, right? And then we have the link CD, right? CD, right? Then we have the link BE here, right? The link BE, right? Then the link DF, right? So this is the link DF, right? And this is the link FG, this one FG, and this is the link EG, right? So now links are clear, right? But here we have a roller support. Be very careful. No, here we have a roller support, right? You know, something similar to that, you know, tire and road connection, right? Because there we have a point of contact. The point, right? So now in this problem we have to be very careful, right? Okay. The first thing is to find the number of members, right? So let's say number of links, right? That is the first target, right? Now here also we have a piston, right? Now here we have a piston, right? Piston or a slider, right? But now here this slider is connected with the ground or with the base, right, through some rollers, right? So what is the interface between the slider and the rod, or not the rod here? So what is the interface between the slider and the ground, right? Now this is something like the ground, right, or the base which is at rest, right? Because now we know that always the base is at rest, right? So now what is the interface between the piston and the base? We have rollers. So it is a kind of a roller support, right? Roller support, right? Now first let's calculate number of members, right? So this slider is a one member, right? This slider is a one member, but before that, what is the first member that we are going to consider? The base, right, or the ground, right? So first we will give the label number 1 to the ground, right? Label number 1 to ground, or in other words the base. So what is the second member? Is the piston. So this is the second member, the piston, right? So here also we have the labeled one, right? And third member is the link AB. Fourth member is the link CD. Third member is AB. Fourth member is CD. Then fifth member is BE. BE is the fifth member. Sixth member is DF. DF is the sixth member. And seventh member is FG. eighth member is EG, right? See, this link EG is the eighth member, right? So how many members we have here? We have total 8 members. That means we have total 8 links, right? So that is clear to you. Now be very careful. Next target is to find, now let's focus. Here, do we have any higher pairs? HP. Do we have any higher pairs? H. Yes, we have one higher pair. That is the interface between the interface between this piston and the base, right? So there we have a higher pair, right? Something similar to the connection between the tire and the road, right? So such type of mechanisms, we call them as what? A higher pair, right? Right. So do we have any other higher pairs? No, right? So here we have many different rollers, right? See, 1, 2, 3 like that, but so we are not going to say higher pair 1, 2, 3, 4 like that. So this entire this entire roller support, right, we take it as 1, right? That means we have one higher pair. That is the point, right? Now you understand, right? That is the point you have to understand, right? And here there's a very special case that you need to know. Now just consider this one. Now this link AB is first connected to the piston, right? I will write it. Link AB is first connected to the piston or the slider, right? But the slider is connected to the base through a roller support, right? You understand? You got that point, right? So from that this link AB is connected to the piston, right, with a certain joint, right? So there we have a joint, right? But if I want to consider the connection between this slider and the base, right, that we do not consider as a joint, right? That is not a joint. That is actually what is that? That type of a joint, we call it as a higher pair, right? HP, higher pair. So the connection between the base and this piston or the slider is not a joint, is not what we consider as a joint. That connection we consider as a higher pair. So we have one higher pair. Now I hope you got the point, right? Okay. Next thing, number of joints, right? So how many joints now we have? We have one joint with the link AB and the base. We have one joint. For what? With the link AB and the base, one joint. Then second joint. Second joint is the connection between the link CD and the base with the help of this pinned connection, right? Link CD and the base with the help of the pinned connection or with the pinned joint, right? So that is the second joint we have, right? First joint is the connection that connects the link AB to the slider, that is joint number 1. Second joint is the joint that connects the link CD to the base, right, with the help of this pin joint. Now here we have a pin, right? So that is the joint number 2, right? Okay, joint number 2. Then this one is the joint number 3, joint number 4, this one, right? And this one joint number 5, this one joint number 6, this one joint number 7, and this one joint number 8. And the last joint is this one, joint number 9, right? So how many joints we have? So we have 9 joints, right? Let's take a look again, right? What is the first joint? Is the joint that connects the link AB to the slider, joint number 1. Second joint is the joint that connects the link CD to the base with the help of this pinned connection. So 2 joints. Third joint is this cross connection, right? Because here also we have a joint, the cross connection between the link AB and CD. So that is joint number 3, right? Then we have joint number 4 is the joint that connects the link CD to the link DF. That is the 4th joint. Here we have the 5th joint is the joint that connects the link AB with the link BE, right? Okay, right. And again we have a cross joint or a kind of an or a joint that is placed in between the intersection, right? So that is the joint that is placed at the intersection of the link DF and BE, right? So that is the joint number 6, the cross joint here, right? Then the joint number 7 is the joint that is there to connect the link DF with FG, right? So joint number 7 is the joint that connects the link DF with FG. Then joint number 8 is the joint that connects the link BE with the link EG, right? Then 9th joint is the joint that connects the link FG with EG, right? So total 9 joints. So now we got the point, right? So that is how you should analyze the number of joints, right? So you have to be very careful, right? Now, by considering the degree of freedom formula, 3 times number of links minus 1, 7, minus 2 times number of joints, 9, minus 1, that is because 3 times 7, 21, 2 times 9, 18, minus 1. So 21 minus 19, the answer is 2. So number of degrees of freedom is next question, right? So now here, now this member, right? Can you see that? So this member is something like, let's call it a cam, right? And this cam is connected to the base, right, or to the ground with the help of this pin joint. Now here you can see pin joint, right? Pinned joint, right? So this is the cam, and this is something like a wheel, right? That is a wheel, right? And that wheel is again connected to a link. Can you see the link here? See the link, right? So this is a link, right? So for the betterment, let's give it a name, link AB, right? Okay. And this link AB is connected to the base with the help of the pinned joint, or with the help of the pinned connection, right? Now what is the first thing is to find number of members, that means number of links. So how many links we have? Anyhow, we know that the first link is given to the base, right? We know that the first link is given to the base, right? So base is number 1, right? So let's name base is number 1. What is the second link? Second link is this cam, right? First one is the base, second link is the cam, right? Second link is the cam. What is the third link? Third link is the this wheel, right? Third link is the wheel. What is the fourth link? Fourth link is this connecting rod, or this link AB, right? But be very careful. You cannot name like you cannot name as link 3 and link 4, because the reason, now see, this link AB is actually welded to this wheel, right? So it is a welded joint there, because this wheel is actually welded to this link AB, right? So you cannot say 3 and 4. On behalf of both these members, wheel and the link AB, we have to give only one label, that is label number 3, right? So how many members we have? That means we have only 3 links. Now I hope you got the point. So we have only 3 links. Then number of joints, right? We have one joint, is the joint that connects the cam to the base. That is one joint because of this pinned connection. The joint that connects this cam to the base. So that is one joint. What is the second joint? Second joint is the joint that connects this link AB to the ground with the help of the pin connection, with the help of the pin, right? Or with the help of a pin, right? So that is the second joint. So one joint here and the second joint is over here. So we have total 2 joints. We have total 2 joints, right? Then what can you say about this interface? The interface between this cam and this wheel. Because if you are going to consider the interface between this cam and this wheel, here you can see there is a line of contact, or there is a particular point of contact. So it is like a what? It is like a higher pair, HP. So it is like a higher pair. So there we have one higher pair also, right? So there we have one higher pair. So then what is the answer for degree of freedom? 3 times link minus 1, 3 times 2 minus twice the number of joints minus 1, 3 times 2, 6 minus 4 minus 1, 6 minus 5, the answer is 1. So answer for the degree of freedom is 1. So now this is a, as you can see here, this is a one single plate, okay, right? So this is a link, right? A link AB, right? And this is a link CD, right? And this is the base or the ground, right? And here also what you can see is the base or the ground, right? And AB, CD, E, F. This is the link EF, right? See this one. And this is link FG. This is the link FG, right? And this is the link GH, right? Link GH, and this is the base or the ground, right? So now first of all, let's see how many links are there, right? Number of links, right? Right, that means let's see number of members, right? So now first of all, you know that the first member that we are going to consider is the ground, right? Or the base, which is at rest, right? So that is the first member, right? So here also we have ground, number 1, right? So this is also number 1 because it is the base. So this is also number 1 and this is also number 1. So number 1 is the base, right? Okay. Then second one is the link AB, right? Third one is the link CD, this one. Then fourth one is the link EF, right? Fourth one is the link EF, and fifth one is the link FG, right? FG. Sixth one is the link GH, right? Is that all? No. Here we have this single plate, right? So that is the seventh link, right? Plate. Right. This one. So we have total 7 links, right? But now here you have to consider something. Now just focus here, right? Here if you are going to consider the interface, right? Or in other words, how this plate is connected with this link FG, right? Now see, this is the link FG, right? So there you can see, we can observe a point contact, right? Because here there is a particular point that is in contact, right? Or there is a kind of a line of contact. Here, see here we have a line of contact, right? So this interface we can identify as a higher pair, right? You got it? So we have one higher pair, right? So H is 1, right? That means how this single plate meets this link FG, right? Because there is a point of contact or a line of contact. So there we have a higher pair. So H is 1. And next thing, how many joints we have, right? Okay. So this link AB is connected to the base with the help of a pinned joint, right? Here also the link CD is connected to the base with the help of a pinned joint, right? And here also this link EF is connected to the ground with the help of a pinned joint. And here also the link GH is connected to the base or to the ground with the help of a pinned joint, right? So how many joints are there? Joint 1, joint 2, joint 3 and joint 4. 4 joints are there, right? 4 joints. Then joint 5 and joint 6, joint 7 and joint 8. So how many joints we have? We have 8 joints, right? Again see, joint 1, 2, 3, 4, joint 5 is the joint that based upon how this link AB is connected to the plate, right? So that is joint number 5, right? And this is joint number 6. Then joint number 7 over here and joint number 8, right? And here if you are going to consider the joint, you should know why that particular joint is there, right? What is the purpose of that particular joint, right? Like I am again telling that don't just say there is a joint like that, right? You should recall what is the purpose of the joint, right? Because what is the purpose of this joint? That is the joint that is required in order to connect this link AB to the base. This is the joint that is required in order to connect the link CD to the base. What is this joint? That is the joint that is required in order to connect the plate, in order to connect this plate alpha to the link AB. This is the joint that is required in order to connect this plate alpha to the link CD. Right? And this is the joint that is required in order to connect the link EF with the link FG at the end F. Right? And this is the joint that is required in order to connect the link GH with the link FG at the end G, right? So like that you should know the reason, right? So now let's calculate what is the degree of freedom there. So 3 times number of links minus 1, 3 times 6 is 18 minus twice the number of joints, twice 8 is 16 minus higher pair, so 18 minus 17, answer is 1, right? So first of all let me label the links, right? Because you can easily identify, right? Link AB, right? So this is the link AB, right? Then we have the link BC, right? And here we have a piston, right? The piston, right? Link AB, BC, then link CD, right? And here we have a plate, a one single plate. So let's give it a name, plate alpha. And this is the link EF, right? Link EF, right? And this is the link GH, right? Link GH, right? And this is the base, right? Or the ground, right? And this is also the base, in other words, the ground, right? So here also we have a base, right? Or in other words, what we call as the ground, right? Because there should be a particular base which is at rest, right? In order for this connection to happen, right? In order to connect this link EF, we need a certain base, right? Okay. So this link EF is connected to the ground with the help of a pin connection, right? Or with the help of a pin joint, right? Right. So you know that, right? So here also the same scenario, right? The link AB is connected to the base with the help of a pin joint. Right? So here also the link GH or HG is connected to the base with the help of a pin joint. Right? And here also, if I am going to consider this piston, right, or in other words, we can call it slider, right? Right. Now this slider moves. Actually, this slider moves along the ground, right? Or in other words, this slider moves along a certain base, right? Right. Towards, front direction and the reverse direction, right? Towards front and back. Okay. Now let's label. What is the number one thing? We have to find number of links, the number of members, and this question is very easy, right? Here, do we have any higher pairs? H, do we have any connections such as tire rod connections or geared mechanisms? No, so no higher pairs. So H is 0. We don't have any higher pairs, right? So how many links we have? You know that the first link is the base, which is at rest. Number 1 is the base. So number 1, right? That is the first label. Right? Number 1. Then number 2 is the link AB. Number 3 is the link BC. Number 4 is the piston, right? Number 5 is the link CD. Then number 6 is plate alpha. Then number 7 is link EF. Then number 8 is the link GH, right? So that is number 8. So how many links, how many members we have? 8 members, right? And how many joints we have? J. Yeah. So now here we have one joint, right? Because that is the joint that is required in order to connect this link AB to the base, right? So here we have one joint, second joint, and third joint, right? So joint number 1, 2, 3. Joint 4, and here we have a very special case that we have to analyze very carefully. So let me teach you that. I think it's better if you write the joints, right? Because that is a very special case, right? So what is the first joint? First joint is the joint that is required in order to connect the link AB to the base. So let's write like that, AB to base. Second joint, let's say that is the joint that is required in order to connect the link GH to the base. Okay. Third joint is a joint that is required in order to connect the link EF to the base. Okay. So that is okay. So this is clear, clear and clear. Fourth joint is the joint that is required to connect the link AB with the link BC. That is the fourth. And okay. Then fifth joint is the joint that is required to connect the link BC with the piston. Be very careful. Fifth joint is the joint that is required to connect the link BC with the piston. So one joint. Then another joint is required. Joint number 6 is required to connect the piston, again the piston with the link CD, right? Again the piston with the link CD, piston with CD. One joint is required to connect the link BC with the piston, then again piston with the link CD. But you can consider that in this one also. The joint that is required to connect the link BC to piston, and then another joint is required to connect the link BC with the link CD. So you can consider that in that manner also. Right? And we need another joint also. What is that? We need another joint, joint number 7, to connect the piston with the ground, right? And there should be another joint in order to connect the piston, right? In order to connect this piston with the base, right? Ground or the base, right? There should be another link in order in order for that connection to happen, right? What connection? The connection between the piston and the base, right? So that is the joint number 7, right? You got the point, right? Then joint number 8 is the joint that is required to connect the link CD with the plate alpha. CD with the plate alpha, right? Okay. I hope you got it, right? Then joint number 9 is required in order to connect plate alpha with the link GH. Right? That is the joint required in order to, joint number 9 is the joint required in order to connect the plate alpha with the link GH. Right? Then joint number 10, what is joint number 10? That is the joint required in order to connect plate alpha with the link EF, right? Joint number 10 is required in order to connect the plate alpha with the link EF, right? Link EF, right? So it is better if you can write like that. What is joint number 1? Link AB to base. Second one, GH, link GH to base, right? So better if you can write like that, because still you are at the initial stage of studying these fundamentals, right? So better write. Now see, this one is a very special case because there are 3 joints. One joint is the joint that connects BC to piston, then piston to CD, then piston to base, right? Very special case. So now you know we have 10 joints there. So then what is degree of freedom? 3 times number of links minus 1, 21, minus 2 times number of joints, 2 times 10 is 20. So what is the answer? The answer is 1.